certainly 0.5, 0.4, you're okay with the ANOVA. You have options though. You can just do a Welch F test or a Brown-Forsyth test if you're in the 0.80 or greater variability in your variances with 3 or more groups. You can still do the Welch or the Brown-Forsyth. Now, if you can't do Welch's t-test or f-test, and you can't do the ANOVA or the regular t-test, then you might consider bootstrapping your p-value. And what you should not consider doing, I'm going to talk about bootstrapping in another video. I don't think it's a complete solution to all problems, but it could be a solution to this in this case. You should not consider doing Mann-Whitney-U or Kruskal-Wallis. This is one of those big misconceptions out there, I think, that if you violate assumptions like normality or homogeneity of variance, then you can do a Mann-Whitney-U or a Kruskal-Wallis. Not true. These statistics have assumptions that people would be very surprised by, and one of them is that the shapes of the distributions are equal between groups, and I think people would be surprised at how non-robust the Mann-Whitney and Kruskal-Wallis tests are. I don't really recommend them at all unless your data truly are ordinal in nature. Even there, I would try to find a way not to do it, but you might be stuck in some cases. I'll do another video on that. These statistics are not robust. Now, factorial ANOVAs, this is a big problem because so many times we have more than 2 independent variables, or more than 1 independent variable. What can you do? Well, you can't do Welch or Brown-Forsyth in these cases. And the simulation studies haven't looked, to my knowledge, at those cases of heterogeneity and variance and on non-normal sample sizes, non-normal distributions, unequal sample sizes. And you can't do Welch or Brown-Forsyth in a factorial ANOVA context. And so what I'd recommend you do in that case, if you have if you got differences in sample sizes and you have variance in if you got heterogeneity in your variances, then you might consider random sampling from your larger sample. So if you had a sample size of 20 and the other sample size was 40, you might consider random sampling 20 people from the group of 40 to make your sample size 20, so that both of them are 20. There's a trade-off in power there, but you're pretty much stuck, I think. And I have another video on how to deal with unequal sample sizes and unequal variances in this context. And I erroneously said in that video that you can't use Welch's test or Brown-Forsyth because they need equal sample sizes. They actually don't. The Welch test and the Brown-Forsyth do not require equal sample sizes. I made a mistake there. Yeah, so there's another video on do that. Here are the references. The Bono, I didn't mention that in this case here, but it's in this video here, but it's a classic paper looking at violations of assumptions of the t-test in the context of heterogeneity of variance and sample sizes. And here's the Havlicek and Peterson study. Here's the Poston study. He said more like 20% difference in sample size is acceptable rather than 40%. And here's the Ramsey paper that I cited in this video. So I hope you enjoyed this. Very complicated once you start manipulating all the variables like sample size and distribution, levels of skew. But I hope there's some guidelines there that you can use, and I think in most cases you'll be okay. But when you're not, you have some options. So I hope you enjoyed that, and I'll catch you next time.